Sorry. Yeah, I'm gonna do my intro here. Okay. Thank you for everyone who came today. Today I'll go over contrarian value investing with machine learning. And so our objective is to evaluate if a stock is undervalued or overvalued using ML, and then short undervalued stocks and long overvalued stocks. And these are our own like value investors are typically seen as contrarian investors. Like they tend to be like grouped into like investors who are called contrarian investors, and they buy stocks that they believe are undervalued and wait until they reach a fair value or they become overvalued and sell them. And typically don't short, but whatever, that's behind the point. And so we are contrarian to the mainstream value investing philosophy. Instead, we are going to short undervalued stocks and long overvalued stocks. It's like sort of counterintuitive, but that's the point. That's what contrarian investing is. And that will be how we will execute our cosmos intellect. You guys know that expanding brainy? Oh, hello. Hello, Serena.
What does it mean to short a stock or a long stock?
Oh, that's a good question. So when you go long on a stock, you basically buy the stock. And
Oh, I see. It's like
yes.
a different term for buy and sell.
Yeah. So going long means you buy the stock. You want the stock to go up. Short the stock is you want the stock to go lower. So what you can do is like brokers have like shares that you can borrow. So you can sell it at the current market value. You borrow some shares, you sell at the current market value, and then you wait for it to go down, and then you buy it back and return the shares to the broker. They typically charge like a little bit of like a few percent as like the commission for letting you short a stock. Mm-hmm. But yeah, that's basically short strategy. So long, you want the stock to go up. Short, you want the stock to go down. Okay, so I've broken down to 6 steps. This is a really good like a strategy for like breaking down machine learning problems. So the steps are we need to get the data, because when you have a machine learning model, you need data to train it. Well, that should be kind of obvious. And then yet, like the data is not always like perfect. So you have to prepare this data, like cleaning it, normalizing it, and adjusting the dimensions, and like just trying to get it into a form that we can feed into a model. Then we feed it the data into a model, which is basically training it. And then we have to evaluate the model, like if the model actually works. So say you have like a machine learning model that tries to guess if a picture is a dog or no, it's a hot dog or not a hot dog. But it only gets it right 10% of the time. Then there's something wrong with that machine learning model, right? So, and there's probably something wrong with the tuning parameters, the data sets, or anything. And so these are some bugs that may occur with your machine learning model. So you want to fix those so that you can have a better model. Because next you need to, taking our model, we can create buy and sell signals using the model. And that is our algorithm. And we have to test our trading algorithm. Well, it's not really trading here. Like I want to consider trading it because it's a long-term investment. And so, but like, whatever, it doesn't really matter. So what we want to do is test if this algorithm will actually make money, because that's the point of like studying this. Like if it doesn't make money, there's no point on keep on continuing with learning the strategy, and then we just stop. We go on to a different strategy. So there's a lot of code here. I will upload this later. Okay, so I want you guys to all go to Google Colab. Create a new notebook. And there are a few commands. Okay, so does everyone have all the libraries installed that I said in the... I have some libraries that I want you guys to install. Okay, Serena, do you have all the libraries? Okay, it doesn't matter. Oh, okay, good. Okay. Why is it taking forever? Oops. Oops. I'll just create a new notebook. There's too much stuff in that one. Okay. Okay, so so this is how you install something in Google Colab. Pip install Symfony. You can also do this on your Jupyter notebook. It's up to you, but like if you already have it set up on Colab, then yeah, I'd recommend doing it on Colab. Okay, so the first thing we want to do is import. I already installed the packages, so in Symfony as SF. What Symfony is it's an API that allows you to get data. Here, okay, so first we need to get like data. I'm just gonna call it data one. So I'm gonna change my signature. Okay, so okay. Okay, so variant equals annual, and what this keyword will basically do is so variant annual is just annual data. Okay, so let's see what this will look like. Oh shit! It's not. Oh no, it's not. Okay, apparently. Whatever. Let me just. Okay. Okay, so let's load some data. Okay, that's what we're gonna do. sf.load. So load income. So income. So there's three in fundamental investing. There's usually three sheets that you look at. So there's the income sheet, cash flow sheet, and balance. Yeah, balance. And so income is basically earnings, earnings and stuff like that, like depreciation, like just like basically revenue minus costs, and like a bunch of random stuff with it. And then there's also cash flow, which is very similar to income. However, instead of like counting like depreciation as decreasing profits, cash flow just measures like physical cash that comes in and out. And there's different like cash flow measures. And balance sheet is basically assets, debt. So hopefully you guys know. So asset is basically something you own. Like a car is an asset, house is an asset, and a liability or debt is basically what you owe, like a mortgage, or for in case of a company, it'd be a loan. Okay, so load income. So variant equals annual. So there's different types. So there's different time frames you can get it. If you do variant equals quarter, it do it 4 times. It get the data 4 times a year per year. Okay. Thanks for coming for 10 minutes. Okay, see ya. It's okay. Okay, this will be recorded, so I will post the recording later. Okay.
Nice one person.
All right, next we have to market. We have to specify the market. There's different markets like Canada, US, Mexico, but we want the US. And then we also have to do okay. I cannot remember. Oh yeah. Yeah, let's just look at what this will look like for now. And this the data frames are stored to RAM. So when you change the data frame, it changes what's stored on the RAM as well. So make sure that you do a copy, or else you like do some. You just want to do copy. So sf.set. Okay, set data directly just basically sets the random folder that you want to use. I've used this before. Okay, so you can see here. That's how it looks like. So there's a bunch of indices. There's a bunch of there's two indices. If you know, in Python pandas, the thing that's bold, like and slightly lower, these are the indices. So you index it first through A, then you index it through a specific date. However, when we want to process this data into process this data for machine learning, we actually want to reset these indices. So let's do that. Reset index. So let's look at what this looks like now. So we have it like that. Okay. Okay, now we want to load the other sheets. Data 2 equals load this. And then, as mentioned earlier, there's also the balance, which is like assets. That's like. Let me just go over this quickly because it's kind of boring.
Is cash flow same as revenue?
Cash flow is basically cash flow is basic like revenue is used in parts of the cash calculations for cash flow, but cash flow is basically the cash that's coming in and out, like physical cash. Okay, so say you made like $1,000 in profit, right? But you have some business equipment that you use, like cars, like say you're like a pizza chain, and so you have cars for delivery. So say you bring in $100,000 in revenue, and once you take into account depreciation, like all the costs, you get like net profit, which is basically income. And a bunch of these like income stuff is in the income sheet. However, cash flow does not take into account like stuff like depreciation, because like the depreciation, it doesn't really take out any cash from you, right? Depreciation, like when your car depreciates, you don't lose any money. Like you don't lose cash, actually lose cash, right? Does it make sense?
That makes sense.
But so like it's the actual cash. It's kind of confusing. Okay.
Like how is it measured? Like is it like the revenue I got plus the expenditure? Is that cash flow?
No. Here it is. Let me try to explain it. Okay, so say you have a house. No, say we go. So okay, so if your piece of revenue, say you have 50K, so you have 100K in revenue, 50K in costs, and 10K in equipment depreciation, like the pizza dough mixer and the cars used for delivery. These things depreciate. So your net income or your profit is 100K minus the 50K in cost minus 10K in depreciation. You get 40K. However, cash flow will be 100K in revenue minus 50K in like costs that you have to pay with cash. And so cash flow is slightly higher, and it would be 50K. So cash flow does not take into account that physically moves cash around. Like, so like when your car depreciates, your net worth goes down, but like the car, you don't lose cash when your car depreciates. You just lose like, you have like negative net profit on the car.
Car is losing the value, not me.
What?
That's the thing. The car loses the value, not me. So
the car loses value, but you physically aren't losing any cash, right?
I see. Yeah.
So the car loses value, but the cash isn't being taken. Like when you're paying a debt, you have to pay up cash, right?
Yeah.
Or like money. But when your car depreciates, you lose profits on you lose profits because the value of your car goes down, but the cash isn't sucked out of you like debt would take cash from you, right? Hopefully that makes sense. Okay, next we want to get hub equals hub. There's this object in Symfin called a stock hub. US. Okay, and what it basically does is from it you can get a bunch of like signals. So
is this data that we're collecting for a particular company or
what?
Like the data is it of a particular company from Symfin?
Symfin?
Yeah.
It is an API. Symfin is a Symfin is just like a website.
Oh, okay.
I'm not sure I'm not sure if it's a full-fledged company, but I'm pretty sure only one person's running it. So what it basically allows you to do is pull data, whole bunch of data. Yeah, I'm just gonna, I don't want to do this. I don't want to see that. It's kind of weird too. Okay, so right. Okay, so what I'm doing right now is getting some signals. What I really care about in the signals is the market cap. I don't really care about anything else in it. Unfortunately, these three sheets do not have the market cap, so I need to like get it somehow. So, okay, so Yeah, here I'll like once we actually use that, I'll go over more in depth. Okay, next we want to. Okay. Okay, so what I'm gonna do is there's a bunch of what? Oh no. But there's a bunch of like columns that I don't really care. Okay. Okay. So there's a bunch of columns that I don't really want that's shared between like three, like data 1, data 2, and data 3, and I'm just gonna. So what I did was I ran it here while this. Yeah, while that's loading, I'll just copy it. Copy the. Okay, so what? Okay, so there's a bunch of rows that I want to drop. So I'm just gonna create a function. Def drop rows. So it's gonna take in a data frame. Return df dot drop. Okay, so I'm gonna have to specify the axis is 1 because we need to delete the columns. Like axis equals 0, it go from the top row to the bottom row, like go row by row. However, we want to go column by column and delete the columns that we don't want. That's why it's axis 1. If you think about it like in a matrix sense, like dimension 0 is going down, up and down. Dimension 1 is like left to right. Oh yeah. Oh yeah. Okay, so we dropped the rows. Okay, so let's df1 equals drop rows. Okay. Oh yeah, as I mentioned before, like for the 4th data frame, we only care about market cap. So if you, oh yeah. Okay, so there's a package in Symfin called names where you can import a bunch of like strings that will autocomplete. Let's do this. And like instead of like doing like, so the names will do, instead of doing something like column names, you can just put in like a string constant. And then oh yeah. Okay, so I forgot to reset the index of all my data frames, so I just added 2 index reset method calls earlier. Okay. Okay, now we want to merge together. Okay, it's done. Okay, so we only want the market cap from the fourth data frame. Okay, now we want to merge these together. Okay, so we're gonna create a super data frame called super df equals df1.merge df2. So we have to specify column. Oh yeah. Let's see what these data frames look like. Like if there's a bunch of random stuff, right? Or maybe a bunch of like, so there's net income, like report date, the stock ticker. And so what we have to do is merge the data based on, so what we want to do is merge data based on the report date because, and the ticker. Wait, let me print df2. Okay, so something that, okay, you can't see it right now, but there's also a report date column here. So what we want to do is match a report date here with the report date here. Oops. Okay, so let me just print these out real quick and then. Okay, you can see that there's like a bunch of like tickers and report dates. So these are two different data frames. Yeah, something you may notice is that these 5 values are the same as these 5 values. And so we want to use these 2 columns to join together our income sheet and our cash flow sheet. All right, if that makes sense. Okay, so income sheet, df1.merge. So we're gonna do, so the on, okay. And then what we want to do is how, okay, the default argument is inner, so we can just leave it like that. Okay, then we want to merge it with the third data frame, which is the balance sheet. Oops. Okay, let me just print. As you can see here, like there's stuff from the balance sheet. Okay, so what merge does is sort of like the SQL like join or something like that. I actually don't know. I'm pretty sure like it has like some like inspiration from SQL. So what it does, so what it does is it just like adds it to the right, like merge. It just adds the rows to the right. Adds the columns to the right. So there's like, so you can see here there's a bunch of columns. Usually there's only 40 columns, but there's a lot more here because we merged them all together into one data frame. Yeah. To build here, let me just like do a quick example of merge. Okay, so A1 equals.
You could use concatenate. That does it like easier. Like you don't have to individually merge every data frame.
Oh yeah, that's a good point.
So
I just wanted to make sure that, like that the indices. I did it. Well, can you do inner join on concat? I'm not sure. I'm not sure if you can do inner join on concat. Yeah, let's check that. Like, it probably work. It will work, but the thing is like this data is actually pretty good, but in real life? Is it in the drawing?
Yeah, you can do it now. I get.
Yeah, I could try that. Yeah, if we do that. Join. Yeah, okay, that always works. Yeah, okay, yeah, that works too. Yes. Okay, so now we need to join it with the before. Oh yeah, let me print out DF4 real quick. Okay, so I want you guys to pay attention to this report date. Like, it's this report date here. So let me print DF4 real quick. So instead of saying like report date, it's this date. So if we try to join it on date, it kind of be a little weird. So we need to do, instead of like just doing on, we need to do left on. So we can just copy this from before. And then on the right on, you guys saw earlier, you can see right now it says date instead of report date. Okay, so what we need to do is just basically take this. And this is also stored as a string constant within like the symfin.names thing. Okay, let's look at what the super DF looks like now. Oh, I see. Okay, yeah, concat. Okay, I think the problem is that concat, what it did is it created duplicate labels. Do you know if there's a way, like I haven't used pandas concat. Is there a way to like, okay, whatever. Yeah, I'm just not gonna figure it out right now. Yeah, I'm just gonna try to figure out the concat later. I'll just use what I used before. Okay, now it works. So giant data frame. Okay, so we have all the data into one data frame. Okay, that was good. However, there's some like stuff that we don't really want. So let's see what these columns are. So okay, so the shares basically like there's a bunch of random stuff that we don't want. So we're just gonna delete them. Okay, so let's create a new data frame. Let me see. I'm just gonna, so okay, so I had a super data frame. So this is gonna be super filtered column data frame. So super super df dot drop. Okay, so we need to specify what we want to drop. So we don't want that shares basic, right? Okay. Then we don't also, there's also 2 dates. Oh yeah. Oh yeah. I remember what I was gonna say. Okay, so there's a report date, but then there's also a date. However, they're like sort of the same thing. Never mind. Never mind. What? Okay, never mind. Okay, so we're gonna create a new different. Okay. Okay, so this is a common tip for Jupyter, but whenever like you go from cell to cell, you sort of want to just create like a new object because like when you rerun a cell where you like edit one object, like you edit one object, then you go to another cell and then you edit again. When you rerun stuff, like stuff kind of breaks. So that's why I just wanted to create a new data frame here. So that whenever I run methods on SFF, like delete columns and stuff like that, it'll like it'll use superdf, which doesn't change from run when I run it time to time. When I run it the second time, so that's why I put in. Oh yeah, also want. Yeah, this is line of code that I copied from Stack Overflow. What it does, okay, so you can also notice that there's a bunch of -y stuff. It's kind of, so there's -x and then there's -y stuff. Like -x and -y means that like they're duplicate columns, but so they're just like, they take the old columns and just like put a -x and -y to know where it came from. So x is like the left and y is on the right. However, those are like duplicate columns, so we don't really want this. So what it does is it basically drops filter. So what it does is it like filters out all the columns that have like a -y. You can see your -y, and then it just drops them. Okay. Next, we want to. Oh yeah, we want to encode the year into a dummy variable. Like, I think it'd be better to like just delete the date. However, this is just for the sake of showing you how to do dummy variables. Oops. Okay, wait, let me explain what let me show you guys what dummies are. Okay. No. Okay, so a dummy is basically, what it does is it encodes categorical variables so that like, so because like when you feed in data to a machine learning model, it cannot take in categorical data. A1. Oops. So what you need to do is like encode them. Let's see. So say that's some categorical data, and those things represent columns. Columns equals columns 1. one. Okay, so let's look at what this A1 looks like for now. Okay, so if we fed these A, B, C, Ds into our machine learning model, it would not work because string doesn't have a numerical representation. So when you're doing like linear regression, where you take a bunch of numbers and you sort of find the line of best fit through all the data, it doesn't make sense to find the line of best fit through A because it's not real. It doesn't really represent numerical data. So how do we make this into numerical data? So let's just encode one column for now. Hey, oops. pd.getDummies. So you can see here, so you had an A and C here, right? And instead of like, so what it does is it takes this A, puts it here, and C puts it here, and puts a 1 or 0 to represent if it is present or not. And that is how you can transform categorical data into numerical data that you can feed into a machine learning model. So how do we add that back in? We can use concat. Okay, so A2 equals pd.concat A1 dummy axis equals 1 because as I mentioned before, axis 1 represents column wise, so we iterate. So we add the new values on to the end as new columns. You can see here, and that is correct. That is correct. Okay, so then, however, we have the same data represented here and over here. Like you see, col 1 A C, and however we also have A C here. So what we need to do is delete from A2 the column 1, and that is how you do for like one column. So if I didn't, so you could just delete this. And however, what happens if we want to do for multiple columns? We just delete that. Col 1, A2. And we have encoded, what? Okay, oh shit. Here, okay, by the way, wait, you don't really have. Okay, you guys got the point. There's something wrong. I didn't clear the memory. Okay, there's something wrong about like memory. Like when you declare a variable, it stays in memory in the notebook. But okay, just remember how to do it. Okay, so okay now okay, so what? Okay, let's get back to it. So we want to create dummy variables for the year. Okay, so let's get the year. Well, actually, not the year, the date. Okay. Okay, so let's concat the dummy variables onto the data frame. and axis equal 1. Now we have to delete the column, the old columns, the date column, because we have already encoded it for the dummy variables. Okay. Let me take it. Okay. And okay, so now we want to keep some data. Let's keep some data so we can backtest our algorithm. Okay, so let's get 1 year of data. Okay, so backtest data. Oops. Backtest equals date dot dt dot year. So dt basically gets the datetime object. So this value, like when it's doing the filtering, it's like some pandas like datetime thing. So when you do dt, you can get the datetime object, and then you can get the year, and then that is an integer, and then we want to compare it to if it is 2018. However, we do not want to use the backtest same data that we backtest our algorithm on, to train our model on with what we backtest our algorithm on. Okay, so what we need to do for the data is just not use 2018 for training. So not equals. Okay, so actually let's just create this into a new variable just to make it extra clear. So this is backtest data we're going to use to train our machine learning model. ML data we're going to use to train our machine learning model. Okay, however, so there's something else in here. Ticker. You guys remember earlier, there's a bunch of tickers. So let's see. So there's a ticker, and ticker is not really numerical data. So let's just get rid of ticker. So del. Okay, so we have basically. Okay, so another problem with machine learning models is that it sort of gets screwed with non-number values. So let's fill these. Okay, instead of doing in place, it gives me an error when I do in place. So I'm just gonna do assignment here and not use in place. Okay, so now we want to fill the non-number values or NA values with zeros. And usually, so like you can see here, depreciation and amortization. So you can probably implicitly infer that this is 0 because like when there is no depreciation or amortization, like how could it be not a number value? That is sort of weird. So like it most likely means that there was no depreciation or amortization, and therefore it should just be set to 0. Okay, now let's put this. Let's run this. Oh yeah, gotta do axis equal to 1. Okay, so what this does is it sort of tries to find a index where it is shares basically equal x. However, we want to have axis equal to 1. We want to have the axis C equal to 1 because we want to look through the columns and delete the column. That is the basic truth. Okay. Oh, yeah, it is. Okay, actually, I do use the date again, and I accidentally deleted it beforehand, so we're gonna have to do it here. The reason there's a bug earlier is because I deleted the date column, but then I use it here to make some comparisons to extract the 2018 data. So that will not work. So however, okay. Hopefully it will work now. Okay, the reason this bug, okay, I just figured out. Okay, so we are using the report date. Okay, the problem is that like when we merge a column, it deleted the date column because they're basically the same. That's so weird. When I merged it earlier, it kept the date column. Okay, so the problem there was that I was accessing date even though like the date disappeared through the merge. So we need to change it to report date because that didn't get deleted. In the merge, only one of the columns were kept, so and it was the report date that was kept. So no. Okay. And we have okay. Okay, next we will create a model. Okay, so I'm going to use an ensemble. Okay, so from sklearn, okay, dot okay, what a random forest is here. Let's see what a decision tree looks like. So this is a decision tree. And so this is one tree. And when you take a bunch of variables and it splits it up into like, if it's like a numerical variable, it split it up like if it's 0 to 1, like 0 to 5, it split it like 0, 1, 2, 3, 4, 5. Or if it's like 2.5, it just like split it into like some even like thing. And what it does is it keeps making decisions until like it keeps making decisions. It like keep making decisions until like it comes to like the answer, and it forms a tree from like going from the choices down to a the values that you want to predict, or the y values, yeah. And so what random forest does is it takes a bunch of these and averages the decisions. So that's why it's called a forest, because it's like a collection of trees. I think it'd be better if you guys just watch a video on how random decision trees and random forests work. You actually don't even need to know how it works, honestly. However, I think it is good. Like, even though you don't need to know how it works for now, I think it is good to know it. Okay, so Okay, so now we need to, so we have the pandas data. Okay, sorry. Okay, so now we have the, so we have pandas, we have the ML data. However, we want to get it into like a NumPy format. Okay, so how are we gonna do that? Okay, so ML data. So there's something kind of wrong with the ML data, however. Oh yeah, so we want to try, okay, so let me go over the strategy again. Okay, so what we want to try to do is predict market cap. We want to make our model predict market cap because like, when you're say you're an investor and you, okay, so if you don't, sorry, let me go over what market cap is first. Okay, so market cap is the total value of the company, like the theoretical value of the company if you wanted to buy all the shares of the company at once. So say if you're an investor, you buy 10% of a company. Well, how do you make money? Is the market, so you own like, say Apple is, no, say some like some bagel company is like $1 billion and you own 10% of the market cap. That means you own $100 million worth of the company, or 10%. And so if the market cap of the company goes up to like 2 billion, you still own 10%, and therefore your ownership in the company is now worth 200 million. So you pop it at 100 million. And so what we have to do is use different data, like how much money the company earns, the depreciation, how much money it spends on capital expenditures, which is basically investment into new equipment and stuff like that, or maintaining old equipment, or how much money it spends on research and development. And you take a bunch of this data and you try to predict the market cap. And so if you predict, and when you average it out using an ensemble, because ensemble like sort of averages out the results from the tree, when you average out these values, you can sort of get a, like your model would sort of like predict a fair value of a company. Like if it is fair, like relative to the other companies, it is fairly priced, if that makes sense. Okay, so what we will store in the y value is the, so we want to get the capital market cap, and the dot values just gets the underlying NumPy representation. Okay, now we want to get the input data. So ML data. However, if we use market cap within the data to predict market cap, like the machine learning model will just take the market cap and just predict the market cap. Like if you use it's like using height of a person to predict the height in person. So we do not want market cap in our data to help us predict the market cap. So we're going to drop that. Max is equal, and we are going to get the values. Okay, so now, however, we need to split this data because we would need some data to train the data and some data to test the data. Import model of train test split. So okay, so X train, X test, Y train, Y test equals train, test, split. And what this will do is split the data like randomly. The default is 75% for training and 25% for testing. And you want to put in the input matrix, and which is basically the X values, and the output values, which is basically the Y values. And the X values is sort of like the manipulated variable, and Y is the responded variable, like when you're doing like plotting stuff. Okay. Next, we want to train our model, model.train. Oops. Oh yeah, in scikit-learn, it's not trained, it's fit. Okay. Okay, now we want to get some predictive values. What the model predicts for these y values. This is y. Model.predict. So let's test it. So, and then we want to compare the predictors with the actual values. Okay, so now we want to sklearn dot metrics import R2 score. And R2 score, if you're familiar with regression, you would know what R squared is. R2 score is R squared score, basically. And R squared is basically a metric to measure how good your model fits the actual data. Your model's prediction fits the actual data. Okay, so let's see R squared. Okay, you can see here. Okay, so linear regression is a model, right? So R squared, here the model, your line of best fit model fits the data really well. So your R squared is 100%. Here, the data is like sort of random and your line of best fit doesn't really predict anything. So your R squared is kind of low. And fun fact, you can actually get negative R squared when your model is so bad that even a straight line across the like just a straight line like this will predict it better than your model. At one point, I got like a negative R squared of like some value to like 6th power, which is like really bad. Okay, so let's R2 score. So let's put in, so you put in your real values and then you put in what the model predicts. Okay, let's see how this model does. It takes a while because it's machine learning. It's probably better if I use Keras, but I have not used Keras yet. I've only used sklearn. Okay, while that's loading, let's work on our trading model. Okay, so okay, trades.logger import dot logger. Simple logger. Oh my god, that's awful. Negative 4.8. Yeah. Oh. Yeah, let's find a random value though. Okay, whatever. Okay, look. That's kind of awful. Let's just run it again. Hopefully we get a better R squared. Yeah, this is an awful way to like improve your R squared. Just like keep running the model until you get a good R squared. That's absolutely terrible way of doing it, but whatever. Okay. So let's create a logger. Okay, simple logger, what it does is it allows us to log trades. If you wanted to like log 100 shares of like Apple, you do APL. And if you want to short, you just put a negative sign there or sell. Okay, so and if you remember before, okay, so now what we want to do, okay, so let me go over what we're gonna do now. Okay, so we're gonna take the 2018 data. Jesus Christ. Fuck. Okay, so we're gonna take the 2018 data and compute what the model predicts is a fair value for the company. And so we're gonna, and then we're also gonna, so we're gonna take the so we're gonna predict the market cap basically for the 2018 data for stock, like, yeah, for 2018 data. And if the stock is overvalued, we are going to buy it and we are going to sell it in 2020. And if it's undervalued, we're going to short it and cover our position. Oh, nice. 42, the answer to life. Okay, so what random state basically does is it like makes it not random. It's actually kind of funny. Like it makes it deterministic. Like you saw earlier when I ran my model multiple times, because since there's a lot of like random like stuff initialized, every time you run it, you'll get something different for your prediction values. However, when you set a random state, it makes it deterministic. So every time I'll run this, I'll get 0.00028889. And that's what random state is for. And I think this is really good for replicability. Like when someone else wants to replicate your experiment, that's what the random state is good for. Okay. I'm pretty sure there might be a better way, like to optimize the how is it like I probably have to use like some gradient descent to like minimize the cost function to get to this R square value instead of using like testing like random states. Okay, so so we had DF5 and those are okay, let's go back to data 5. Okay, so data 5, so you can see val signals, like the val signals, and this gets the data over like many years. And for however, we only wanted the market cap column. And when you set the variant to latest, it just gets the latest values. One time, like May 11th or May 12th, the latest values, and well, like, yeah, just the latest market caps. And so we want to clean this a little bit. Okay, latest prices. Data 5. Okay, so there's a problem. Okay, so let's look at this latest here. Okay, as you notice, there's some about like for this value, it is not in 2015. That probably means that the company went bankrupt in 2019. So, however, so we cannot buy that stock. So let's just get rid of it. Okay, so latest DF equals. So how do we filter that out? Latest DF. So we want to get to daytime dot. Yeah, so we want to get the date. What? So we want to get the only the 2015 years. Okay, so datetime dot dt dot year equals 2020. And you probably want to do May too. Yeah. Because a lot of companies are going bankrupt these days. So what you have to do to like do multiple filtering things. Wait. How do you do because like with the coronavirus, probably a lot of companies are going bankrupt these days. And so we want to do for May, like the companies that are still surviving in May. So actually, let me just oops. Wait. Oh shit. Wait, these are all the companies that went bankrupt in April. I'm at 5. It's pretty funny. Okay, so let's.
So get her list.
Okay, so there's a ticker. Oh shit. Oh yeah, there's only a few columns that we want. Ticker.
If you have her.
Okay, so now this is kind of okay. Now we want to set the index. So if you saw earlier, the indices were all integers. However, we want to set it to the ticker because it will make accessing. Oh shit.
It is
okay, so we want to set it to the ticker because it'll make accessing the data a lot
easier. I'm always confused with this two. One is ATORVASTATIN. That's one. Another one is LASARTAN. Which one is for blood pressure? The Saturn. Torvastatin. Either one of this. One is for lower blood pressure. One is for lower cholesterol. Let me do some research real quick.
Sorry.
Do you know which one is for lower?
Sorry, guys, just know that was something.
Isn't it one dude brother?
Okay, so okay, now we want to okay, so if you remember earlier, we like sectioned off a little bit of our data for backtesting our algorithm. Okay, so let's iterate of the index. Okay, so let's get a row. And if you remember, for column wise, no, for row wise indexing, you do low. So index. So let's get the ticker, let's get the market cap. And this is real data. So we're getting the actual market cap here. Okay, so the reason we have to put this in a try except block, value is because sometimes these companies go bankrupt and they don't appear as data in like the past or in the present. Like say a company like IPO'd in 2019, then they want to appear in like 2018 data, right? And so sometimes when you try to access this data, when there's no key, that means there is no data available for that year that you're trying to get it. And so what we can do is break out of the loop because we don't have data for those years. Okay. So what we're gonna do is buy 1/1,000,000th of a company. So buy 1/1,000,000th of the market cap of a company. So 1e6. Okay, in Python you can do something called 1e6, and that's scientific notation. If you're familiar with scientific notation, it's 1 times 10 to the 6. Now we want to get the
对对。
oh yeah, so we also need to get the current market cap. And if you remember, if you remember from earlier, we got the latest data. So latest is current. So we want to get the current market cap. So market cap curve equals, okay, and so we want to get, so to access that data, we have the ticker here. So let's get the current market cap for this ticker. So latest DF, that is where we stored the market cap data, and let's get. Oh yeah, I forgot. Row-wise indexing. Oh yeah, we also get the market cap. Okay, so we're just gonna buy those. So say you own like 10% of a company, like back then. You sell 10% of the company now. Then you just sell that 10%. Okay. Yeah, position is just basically scaling down how much we have of a company. Okay, next we want to predict. Oh yeah, let's create a function called predict, def predicts, and we'll pass in data into a model. Okay, so data. And if you remember from the previous workshop, it has to take in 2-dimensional data. So even if you pass in like a row of data, which is 1-dimensional, just stick in here, you can get it. And it also returns 2-dimensional data. However, it's 2-dimensional, yet it only has 1 element. So to just get the value, you just index it as 0. Okay, now we want to oh yeah. Sometimes there's not a lot, like if you remember before, we filled in all the not a number of values with 0. However, like sometimes market cap and market caps or some data just gets filled in as not a number. And so we have to make sure that we only trade position size that are greater than 0. So this is another filter to filter out bad data. Yeah. Okay, so now we want to log a trade. Oh yeah, so now we want to take our, oh yeah, let's get the predicted value. Predicted. Predict. Oh yeah, we need to get the row model dot. Okay, so our row has 2 extra columns that we did not use. Ticker. If you remember earlier, we deleted ticker in the for the training data. We deleted ticker. Yeah, I can show you. So here, if for the training machine learning data, we did delete the ticker, but we kept it for the backtesting data because we wanted to use, we need to use the ticker to be able to access to know what stock the current row corresponds to, and then we can access the current market cap of that company. Okay. So we need, however, to make sure that the input data is the same dimension as the data, has the same columns as the data, has the same like columns, yeah, same column, both in like, the same columns. Okay, it has the same columns for the input data for the model, so that, okay, so it has the same columns for the input data as the training. Sorry, okay, just ignore what I said. It'll have the same columns as the training data so that it can make a prediction on an input value. Hopefully that makes sense. And also, because we had made the market cap into the Y, we stored the market cap into Y and deleted it, and we dropped the market cap here. Yeah, if you remember, we did drop the market cap here. We also need to delete the market cap for input data so that we can have the input data match the same dimensionality as the training data. Oops. Okay, so what that does is it predicts the market cap based on the fundamental data that we pass in. Okay, now if our predicted is if it is like 90% of what is considered, if the fair value is 10% lower than the current, if a fair value for the company is 10% lower than the current market cap, that means the okay, so if the if the market cap that we predict is 90%, okay, never mind. We are buying undervalued. Okay, so if the predicted is 90% lower than market cap, that means the company is over. Shit. This means the algorithm actually predicts that the company is overvalued. Okay, yeah, I talked about. Okay, so earlier I talked about like shorting undervalued companies and longing overvalued companies. I still think that's wrong. Okay, just ignore that. Security equals ticker. Set ticker up here. Okay, so let's just shares equals 1. So instead of like specifying like how many shares we're gonna buy, we're just gonna specify our position size. Share So and we are going to, so we're going to buy it at the 2018 price. And then we are going to sell it. Okay, thanks for coming. Okay, so, and then we have to sell it at the current price. Okay. And if it's 10%, we just want to do this, but reverse. Okay, so what this does, if it predicts a market. Okay, so what this does is okay, so what this does is if thinks it's the company is overvalued, then it shorts the company. And let's see how it does. Okay, I forgot a capitalized sticker here. Oh, we need to fix our back tester. Okay, so the problem. Okay, so the fix is Okay, so to fix it, we have to fill it with zeros. Fill the 9 number of values with zeros. So here, let's. Let's keep it here. Yes, it works. Yay, it works. We made money. Holy shit, we made like 1.6 e to 11. I don't know how much that is. It works. Okay, that is about it. 11. That is about it. I hope you guys enjoyed this lesson, and that is about it.